In this video, we'll be evaluating limits of functions at some point. All the functions what we see here are in terms of x, so we'll try to find the limit of the function as x goes to some numbers. You know the process. First we are going to insert the numbers directly in place of x, then we will see the result. If undefined or some kind of meaningless result happens, so we'll try to design some other kind of technique. Let us see from the first one. The first question, the limit of x minus 3 the whole over square root of x square minus 6x plus 9. First let's try to insert. When we insert 3 directly, it will be the upper part will be 3 minus 3, and the lower part 3 square minus 6 times 3 plus 9, the whole under square root. This is the same as 0 over 0. 9 will be 18, here also 18, but this is negative 18, so everything will be cancelled and 0 over 0 will happen, will be the result. So this is undefined or meaningless, so this is not preferable method. Direct substitution doesn't work. So what to do? When you try to see the square root part, it is a quadratic and it can be factorized. It says x squared minus 6x plus 9. To factorize quadratic, let us think of two number product, the constant term that's 9, and the sum, the middle term negative 6. Since the coefficient of x squared 1, we can say product simply the constant term. If the coefficient of x squared is some other number, we have to multiply the coefficient of x squared and 9, and then we have to get that number. Okay, this time product 9 and some negative 6 will be negative 3 and negative 3. When you multiply, it will be 9, and when you add, it will be negative 6. So let us bring them x minus 3 times x minus 3. Again, since the coefficient of x squared 1, we can directly take them, but the two are the same, so we can write it x minus 3 squared. So this, the whole thing under square root, will be the denominator part. But when we take out this one from the square root, because the square root and the square cancel each other, it will be absolute value of x minus 3. We cannot take it out as it is directly. Since it contains variable, we have to put it in absolute value. And this absolute value, it has two possible outcomes. One, as it is, x minus 3, when x minus 3 is greater than 0. And the other one is negative of x minus 3, negative outside, when x minus 3 is less than 0. But what does this mean? X minus 3 greater than 0 means when x greater than 3, when you shift the 3 to the other side. The same thing here, when x less than 3. But we are asked the limit as x approaching 3 means for the right hand limit, when as x goes to 3 from the right, we'll take the first function, that is x minus 3. This will be taken as x goes to 3 from the right side, and this x less than 3 means when x approaching 3 from the left side, so we'll take the second part. So the limit of the function as x goes to 3 from the right, when I say the numerator part as it is, but the denominator will be taken the first function, here it is, so it will be 1. For the second part, the limit as x goes to 3 from the left, the numerator x minus 3 as it is, but the denominator part will be negative of x minus 3, so that's going to be negative 1. But these two limits are not the same. This will be the right hand limit, and this will be the left hand limit. So the limit of this function, we can say, doesn't exist, because the definition of limit says the limit of a function at a point exists if and only if the right hand limit and the left hand limit of that function at that point has to be equal. So this time 1 and negative 1 are not the same, so the limit doesn't exist. Right hand limit and left hand limit not equal. The second one, the square root of x squared plus 1 minus 1 the whole over x squared. When we insert 0 directly, the denominator part will be 0, so it doesn't work. So what to do? We cannot factorize the one which is found in the square root, but we can rationalize the numerator part, you know, x squared plus 1 minus 1 the whole over x squared. The upper part we can multiply by the conjugate of the expression or by the rationalizing. We will multiply the square root of x squared plus 1 plus 1, the whole over, the same thing, the denominator part, x squared plus 1 plus 1. This is going to be the upper part only, you know, a minus b times a plus b will be a square minus b square. So we can consider this one like a minus b, and this would be like a plus b. So when you multiply, the upper part will be a square first. A square means the square root will be cancelled, and x square plus 1 will remain, minus the b square means, you know, 1 square, that's 1. The whole over the down part, x squared, then in bracket x square plus 1 plus 1. Second multiplier as it is will be taken here. Now this time negative 1 and 1 cancel each other, and in the numerator what left? X squared left, the denominator part as you see. But here this x square will cancel this x square because the upper part is only one term we have, so we can write it the limit of 1 over square root of x square plus 1 plus 1. This is under square root as x goes to 0. Now we can insert 0 freely because it will not be undefined. When you insert 0 here, it will be 0 plus 1, 1, square root of 1, it's 1. So finally the answer will be 1 over 2, and that's it. The next one, it says the limit of x plus 1 over 3x minus 1. This time again, when you insert 1 over 3 in place of x, it will be 1/3 plus 1 over 3 times 1/3 minus 1, which will be 3 plus 1 will be 4 over 3, the upper part, over the lower part will be 0. This is undefined again. It is undefined, and at the same time we cannot factorize the numerator and the denominator. Both of them are linear and we cannot extract anything. So we can't do anything. The limit doesn't exist, simply doesn't exist, or it will be undefined. If you try to find the limit of this function as x goes to 1 over 3 from the right, and the limit of this function again as x goes to 1 over 3 from the left, if you insert a number which is greater than 1 over 3 slightly, you will get a positive infinity. Here you will get negative infinity. You know, infinity is not a number. That's going to be x is equal to 1 over 3 will be a vertical asymptote in another way. Since the function is a rational function, when the denominator 0 part will be vertical asymptote. So as x approaching this line 1 over 3 from the right side, it will be positive infinity, or the graph goes up without limit, and from the left side the graph goes down without limit. So this is the limit of this function. We can say it doesn't exist. Next one, the limit of x cubed plus 8 over x plus 2 as x goes to negative 2. Again, if you insert negative 2 up and down, it's going to be negative 8 plus 8 over 0, which will be 0 over 0. Again, it's undefined. So this method again is not preferable. But can we factorize? Yes, the numerator part can be factorized because it is a cube function. Cubic functions like a cube plus b cube can be expanded as a plus b, then a square minus ab plus b square. If it is a cube minus b cube, what to do? The same thing, a minus b and a square plus ab plus b square. There is some difference here. When it is plus here, the first will be plus here, and here the middle minus. When it is minus, the first will be minus here, and the middle part will be plus. That's it. But this time, what do we have in the numerator part? That is x cubed plus 8. This is the same as x cubed plus 2 cubed. We know 8 means 2 times 2 times 2. So we can expand this one by the first formula, x plus 2, then in bracket, x squared minus 2x plus 4. Then the limit will be the limit of the upper part, x plus 2, x squared minus 2x plus 4 over x plus 2 as x goes to 2. Then now we can cancel x plus 2 is x plus 2, and then directly we can insert. It will be 4 minus 4 plus 4, which will be 4. The answer will be 4. This is the limit. Next question. Again, here we have absolute value. First we have to remove this absolute value, because if you substitute 0 over 0 it will be, so the absolute value of x again is equal to x or negative x when x greater than 0 and when x less than 0. Greater than 0 means as x goes to 0 from the right, and as x goes to 0 from the left. We'll take those functions. So we have limit of the function as x goes to 0 from the right. It will be x cubed over x plus x. The absolute value will be removed and positive x will be taken because from the right. This is the same as the limit x cubed over 2x as x goes to 0 from the right. This is the same as 1 over 2x square, or 1 over 2x square, yes, it will be. So when you insert 0, it will be just 0. It will be the limit of, 1x will be cancelled here, x cancel, and the cube will be square. So what remain? X square over 2 as x goes to 0 from the right, which will be 0. The second part, the limit as x goes to 0 from the left, it will be x cubed over negative x plus x. So this will give us undefined, because the denominator part, negative x plus x, will be from the beginning, it will be 0. So this will be doesn't exist. So the right hand limit is 0, but the left hand limit doesn't exist. So generally the limit of this function as x goes to 0 doesn't exist, we can say. This is a symbol for doesn't exist. Next one, the limit of a function as x goes to negative 5. Direct substitution, it will be negative 5 squared plus negative 5 minus 20 the whole over negative 5 squared plus 4 times negative 5 minus 5. This will be 25, and this will be together negative 25. That's going to be 0, the upper part. The lower part also will be 0, yes. 0 over 0, still it is undefined or doesn't work. So let us factorize both the numerator and the denominator, since both of them are quadratic. The numerator part, x squared plus x minus 20. When you think of two number product, negative 20 and sum 1, those numbers will be 5 and negative 4. So we can write x minus 5 and x plus 4. The denominator part, this is the numerator part. The denominator part, x squared plus 4x minus 5. Again product, negative 5 and sum 4. What are those numbers? Obviously 5 and negative 1. So we can write x plus 5 and x minus 1. Okay, let us take here plus and this one minus. Therefore the limit will be, let's change the color. The limit will be as x goes to negative 5. The upper part will be x plus 5 over x minus 4, the whole over x plus 5 over x minus 1. We can cancel x plus 5. This was the problem. Now we can insert directly. It will be negative 9 over negative 6, which is going to be 3 over 2. next function, the limit of sine x plus 1 the whole over x plus cosine x as x goes to 0. Again, as usual, let us start by direct substitution. When you insert directly the 0, it will be sine 0 plus 1 over 0 plus cosine 0. This is the same as sine 0, 0 plus 1 over, and the lower part 0 plus cosine 0 is 1. So that's going to be 1 over 1, that's 1. So the limit directly, by direct substitution, the limit exists, so this is the limit. Next one, the limit of square root of x minus square root of 2 the whole over x minus 2 as x goes to 2. If we substitute directly, square root of 2 minus square root of 2 over 2 minus 2, which will be 0 over 0, again doesn't exist. But we cannot conclude. First we have to try to check if we can factorize or rationalize. So our function is square root of x minus 2 square root of x minus square root of 2, I'm sorry, the whole over x minus 2. Let us rationalize. The numerator can be rationalized, or we can multiply by the conjugate of it. It will be square root of x plus square root of 2 the whole over square root of x plus square root of 2, which will be the upper part, again as I said before, a minus b times a plus b. It will be a square minus b square. So x minus 2 remain up, down, x minus 2 times square root of x minus square root of 2 remain. We don't have another choice, just multiply. Then here x minus 2 cancel with x minus 2, so the limit of, as x goes to 2, what left? 1 over square root of x minus square root of 2 remain. Now we can directly insert 2, it will be 1 over, this is plus, because this must be plus here, square root of 2 plus square root of 2, which is square root of, 1 over 2 square root of 2. If you rationalize, it will be root 2 over 4. Either this one or this one can be the answer, so it exists. Next one, again some kind of longer function, but as x goes to 2, it says if you insert 2 minus 2 root 2 plus 1 the whole thing in the square root, then minus 1 over square root of 2 minus 2. So by direct substitution we got this result, but this result can be simplified. Actually the denominator part is not 0, so it's a number, and we can leave it as it is, but just for further simplification we can write the square root part, only this part. We can write it square root of 2 square minus 2 times square root of 2 times 1 plus 1 square form. I can write it, only the inner part. This is the same as like a square minus 2ab plus b square form. This is the same as a minus b the whole square. So this is the same as square root of 2 minus 1 square. Now the square root part will be square root of 2 minus 1 square, then minus 1 is there up outside the square root, then root 2 minus 2 remain. This is the same as, since the inner part here it is root 2 minus 1 is greater than 0, so the square root and the square cancel and directly can be extracted. Square root of minus 1, then minus 1 remain over square root of 2 minus 2. This is equal to square root of 2 minus 2 over square root of 2 minus 2, which is equal to 1. We can keep it the answer. Without rationalizing, by substitution, we got something that's not undefined. We can really leave it as it is. What I did after this is just to simplify and write. So this means equal to 1. By simplification, we have got the result 1. At last, the last one, it says square root of x minus 1 plus square root of x minus 1 the whole over square root of x square minus 1. Again, if we insert directly 1, it will will be 1 minus 1 in the square root plus square root of 1 minus 1 the whole over 1 square minus 1 in the square root. It will be 0, this will be 0, everything will be 0. So 0 over 0 will be undefined. So this is not preferable. Or let us try another way to simplify or to get something. The numerator part, the bracket, the square root part can be factorized. X square minus 1 we can write as x minus 1 and x plus 1 form. But let us try to be systematic, because the denominator part, since the whole square root means this will be the whole square root, this will be the whole square root, or together in one square root you can put it. But here the numerator, the first addend, it contains this part. So let us separate it. So the limit will be, without the limit, square root of x minus 1, the upper part, square root of x minus 1, the whole over square root of x square minus 1 plus square root of x minus 1 over square root of x square minus 1. We can give the denominator for each. Let us consider as two addend, like this is like 1 is like another one, like a plus b. Let us consider them, then we can give the denominator for each. But the first part here, we can write it square root of x minus 1 the whole over, since as I said before, this one will be written as square root of x minus 1. It has two factors, square root of x minus 1 times square root of x plus 1. Then this is going to be cancel each other, so what remain? 1 over square root of x plus 1 remain. In this one we can insert, or we can find the limit. As x goes to 1, directly if you insert, we'll get 1 over radical 2. Okay, let us keep it. And then plus is there. Let us go on for that. For the denominator part here, it will be square root of x minus 1 over square root of x minus 1 times square root of x plus 1. The problem is square root of x minus 1, this one. So let us remove that. For that purpose, let's multiply by root 2 square root of x minus 1 by itself, because square root of x minus 1, because it's together. So it will be the upper part, square root of x minus 1 times square root of x minus 1 together. This is minus 1 is together inside, the whole over the lower part, square root of x minus 1, then square root of x plus 1, then times it will be, when you multiply the two, it's going to be, when you multiply the denominator part, here we need to focus, when you multiply this with this, the radical will be removed, and one radical is not there, just this remain. Still we cannot simplify, but the upper part again, we can rationalize it again. The upper part here, we can multiply square root of x plus 1 over square root of x plus 1. We can multiply the upper and the lower, then let us see what remain. Upper, when you multiply the two, what remain? X minus 1 remain, and in the second bracket what we have? Square root of x minus 1 is there already, the whole over the lower part, x minus 1 was there, and again square root of x plus 1 still there, times something new here, square root of x plus 1 is there. Now it's fine, we can simplify x minus 1 here, it goes. Now there is no x minus 1 term in the denominator, because the problem is the denominator part that makes undefined. There is no x minus part here now. Now when we insert directly, when you find the limit, I can write it here, the limit of this function. Now as x goes to 1, it will be 0 the upper part, because here 1 minus 1 will be 0. The lower part will be root 2 plus 2, root 2 times 2 remain, because this radical 1 is 1, 1 plus 1 will be 2, but 0 over whatever will be 0. So here plus 0 remain. So the whole limit will be 1 over root 2. If you rationalize it, it will be radical 2 over 2. So we need to be systematic here. What did I do once? Just to repeat, I just divide the first part, this one addend, as what? Like, remember, a plus b over c. If you have, you can write it a over c plus b over c form. So radical x minus 1 the whole over the first, the denominator, here it is, plus the second part, radical x minus 1, I can consider it like one term, the whole over square root of x square minus 1. Then the first part, since this radical can be factorized as x minus 1 and x plus 1, we can write it in two radicals, and then one of the radical cancelled. Then what remain? 1 over square root of x plus 1. Then directly when I insert 1, I got this result. And then let us deal to the second part. When you go to the second part, 2 times rationalizing. First of all, square root of x square minus 1 will be written as x minus 1 and x plus 1 in the square root, and we rationalize by multiplying by x minus 1 in the square root. Here it is. Since it is together in one radical, we will not change any sign directly, and then we got this result. Still the denominator part x minus 1 containing, and then to remove that, the upper part again we multiply by the conjugate of square root of x minus 1. Then we got this result, and x minus 1 from the denominator eliminated, and then this remain. When we substitute, we got 0. Finally the answer will be root 2 over 2. So this is the exercise which is was supposed to be solved for today. Thank you for watching.